Hello and welcome to Microcubic's video tutorial. In this video, we will explore the latest updates to our 3D microscope, focusing on the new version of the MRCL viewer software. Specifically, we will review the new measurement annotations, including circular and angular measurements, as well as height and width measurements during tilted imaging. First, install the software. If you have an older version, there's no need to uninstall it as the new version will override it. To install, simply go to the Setup folder, run the setup file, and follow the prompts. The first thing you will notice in the software is the pop-up window with welcome tips. You can navigate through the different help pages using the next and previous buttons. This space will also be used for announcements, so make sure to check them briefly when you start the software. We have also updated the help menu with direct links to our YouTube page and other resources. Additionally, remember that each section of the software has a dedicated information button that provides useful tips and instructions. Now, let's discuss the key features of the new version. As always, start by connecting to the microscope's COM port and the camera. We recommend using auto exposure in most imaging scenarios. Then, go to the Lenses tab in the Settings menu and import your previously saved lens file. There are two major changes in the calibration table. First, you can now assign custom names to each calibration data entry or lens, making it easier to identify your default and custom lenses. You can also create new calibration data for the same lens but with a different scale bar unit and save it under a separate name. The other change is the introduction of a new data point for calibration at the camera's 100mm position, which provides better accuracy at low zoom levels. While the software will still function without this new data point, we highly recommend checking your calibration occasionally, especially before critical measurements. Please refer to our dedicated lens calibration video tutorial and the user manual for the calibration process. Let's now review the new measurement annotations. You can place a crosshair at the center of the camera preview for easier alignment. As a side note, right-clicking on the camera preview automatically centers the clicked position using the motorized stage. Please note that the scale bar must be activated for this function, but it works whether or not the crosshair is in use. The next feature is the circular measurement. Here, you can adjust the center and diameter of the circle by moving the blue dots. Please note that the circular measurements are accurate for top-down imaging and not trigonometrically corrected for tilted imaging. As a side note, all measurement annotations illustrated here can be used for both Lens 1 and Lens 2, provided that they are calibrated and the correct data is selected from the bottom left scale bar drop-down menu. The other new annotation feature is angle measurement, which displays the angle between two lines based solely on pixel calculations. You can also use this feature for simple contact angle measurements. You can move the camera to its 90-degree position, adjust the viewing height using both primary and secondary tilting axis, and measure the static contact angle of a droplet. For more precise measurements, we recommend capturing a photo of the droplet and processing it using a third-party software, like ImageJ or Fiji with a contact angle measurement plugin. Now, I'd like to move on to the next update, which concerns tilted measurements, an important and highly anticipated feature. We have introduced 3 new annotations for 2D and tilted measurements. Please pay close attention to the distinctions between these 3 modes. You can use the 2D rectangle annotation during top-down imaging, which occurs when the tilt angle is close to 0. However, for larger tilt angles, while the horizontal axis of the rectangle will still provide the correct value, the vertical axis will be inaccurate due to the apparent view of the image caused by tilting. To address this issue, we have introduced a new annotation for tilted width measurements. In this case, the apparent pixel value is divided by the cosine of the tilt angle to display the trigonometrically corrected value. Let's check this using an actual microfluidic chip. The 2D rectangle is used for top-down measurements along both the lateral and vertical axes. After tilting, we can still use the rectangle for lateral measurements. However, we need to use the 3D width annotation for the vertical axis, which measures the channel width. Similarly, to measure the height or depth of a channel, we now have a separate annotation whose value is corrected by the sine of the tilt angle. Note that these measurements assume the sample is flat and the channel walls are vertical. If you have any doubts, you can always align the sample with the horizontal axis and measure without needing any correction for the tilt. Let's now measure another sample using the high zoom lens, a microfluidic chip fabricated on a silicium wafer. As a side note, this lens does not have an integrated infrared filter, so you may need to adjust the white balance depending on the ambient lighting. Otherwise, you may notice a purple tint. For highly reflective samples like silicium, you need to be especially cautious when measuring height or depth, as the sidewalls may appear twice as large due to reflection. Here, we have a photoresist channel that was previously measured at 15 micrometers using a stylus profilometer. We will align the 3D height annotation to the midpoint, where the interface with the silicium surface can barely be seen as a thin line. As in the previous example, you can use the width annotation to measure the channel's width in this tilted view. Please always remember that measurements are accurate only in focused regions and depend on the accuracy of your calibration data. Regarding focusing, I want to mention that the software does not yet support live measurements after focus stacking. As a quick reminder for new users, you can use the automatic focus stacking function to create an image where everything is in focus. Here, the software captures multiple images, while the motorized actuator moves between two selected focus extremes. The built-in focus stacking algorithm works well for most samples. However, we always recommend using the third-party Helicon Focus software for even better quality results. You can simply drag and drop the images acquired during stacking into Helicon Focus to render your final image. You can even utilize its 3D modeling feature, which works best when the Z-stacking is done directly from the top of the sample, without any tilting. When focus stacking is not an option, such as during live measurements or video recordings, please use the provided iris diaphragm for aperture control. Similar to any other microscope or photography system, a smaller aperture results in a larger depth of field. However, you may need to increase the illumination intensity or exposure, as images may appear darker or noisier with smaller apertures. Finally, the new update allows you to capture two versions of the image, one with annotations and one without. This feature was requested by some users so that the original image can be utilized later with annotations in your own style. This feature is enabled by default, but you can disable it from the settings menu if desired. We hope you enjoy the new software update for your microscope. Don't forget to check out our other video tutorials, the user manual, and welcome tips for further guidance. We are continuously working on new features and always appreciate your feedback and suggestions. Please feel free to reach out to us whenever you need support or wish to explore customized projects. Thank you for watching and goodbye.